Alright everyone, welcome back to the next part on this RTS series. So we're going to be working now on something that's not as exciting as the previous videos, but it's nevertheless needed for this type of project. In short, the goal of this video is to clean up the code so we pass the responsibility of inputs towards a new object, which we're going to be called RtsPlayer, and we're going to let the camera only do camera stuff. So I have stripped away from the camera all the input commands and now have been replaced by a new object, which we're going to call it RtsPlayer, and now this object is handling all the inputs. So let's go right ahead and let's open Godot last part. So the first thing we're going to do is start by working here on the nodes itself. So let's go ahead and rename worlds to be our RTS world. So this now will hold our RTS nodes. Let's go ahead and add a child node. Now this child node here is going to be responsible by the player. So let's call this as RtsPlayer. We're also going to be adding a new one, and we're going to be calling these units. And we also are going to add a new one, and this one is going to be called buildings. So let's grab our 10th objects, which are all of these, I believe. And as you can see, it is. And let's rename them all together. So if you select a bunch of them and press F2 while they are selected, let's rename them to 10th. Now you can see all these objects are being renamed to 10th. So now we can just place them inside of buildings and left them there for now. So we are actually grouping them together. So let's go ahead and add a couple more nodes. So inside of our main, we're going to add a control node that's going to be responsible for our UI. And a lot of these nodes are going to be placeholders for our structure for the project as we move along. So we are not going to use them right now, but they are going to be placeholders for the future. So it's like we're building the structure for the project. So let's also rename this one to be our grass. So this is our floor here, which is our grass for now. And I think that's about it. So another thing now is we are going to change here in the folder system here. So let's go ahead and add a folder, and we're going to call this RTS systems. And we're going to now drag and drop our RtsCamera inside of it. Now let's go ahead and add a new folder here, and this one is going to be called the RtsPlayer. And as you have guessed, we're going to be placing this one inside of there. So let's go ahead, save this branch as our scene, and let's go to the RTS systems player and let's call this as main. So now we have a RtsPlayer that's put inside of there. Enter its scene, let's add a script to this, and let's put it on main as well. So that should do it. Now we have a main inside the script. Alright, let's save it. Now another thing is that, so this folder here should be actually called node with an uppercase letter. So if you were working on Linux or other operating systems aside from Windows, the script template might not work properly. So I'm going to rename it just so Godot knows how to use this properly, even if you are on other operating systems. So let's do that. Also a new thing that I'm going to change here is on the grass itself. As you can see, it is being filtered. So something I forgot to set it up on our previous tutorial, but we can do quickly here. Let's go under the material properties, and there should be a property here called sampling. So what we're going to do is to remove the filtering of this grass texture to be a little more grainier, and also we are going to apply the anisotropic. So anisotropic, as you can see here on the far distance where the texture is very much angled, if we enable the linear map with anisotropic, you're going to see a little more details on that distance. That makes a difference. So what I'm going to do is switch from the previous linear map to first nearest map. So we're going to exclude all the filter from this texture, and as you can see, it stays very much pixelated. And next we're going to click here and change this to also use anisotropic. So if you check here, you should now see a little more detail on the grass texture, even from these weird angles. So this is desired to keep a nice little effect. So if we run our scene, you're going to see that the grass texture is a little more nicer. Let's start now working on the code itself. Now, something that we're going to be working on is stripping away all the inputs from this object, which is our RtsCamera, and we're going to pass them through our player. So the idea is that this object here should have the function that allows it to rotate, move, etc. But we do not want any input on this object anymore. And the reason for that is because we want our RtsPlayer object to control all the inputs for the player. So we are stripping away the inputs from the camera to pass on a new object which is going to be responsible for that. And that is because we are reformatting the code. So we follow some kind of structure, and the structure is going to use the RtsPlayer to deal with inputs. And this will prove something necessarily because later we're going to have a bunch of complex UI user interfaces commands based on the context of the player, and having an object specifically designed to manage that is going to be much better. So let's go ahead and enter our player here, and I'm going to do a couple of things here. So first, I'm going to add that camera script as a type for this script, and you're going to see why that is useful in just a second. So let me just rearrange here, and let's start coding. So I'm going to define here a new constant, which is going to be our type of an RtsCamera. And I'm going to not define a type, but I'm going to preload that inside of the constant. And here's also a new thing I'm going to show you. What I'm going to do is add a relative folder here. So I know that this folder is neighbor to the other one. So I know that the player is on the same parent folder of the RTS systems. So I can actually ask for a folder upwards from that by doing this. And if I do here the RtsCamera _main.gd, you're going to see that's going to accept this. So what this means, this path here, it's saying that we are going to get an upper path from this folder. So the RtsPlayer is going to access this folder here. Next is going to grab the RtsCamera folder and its main.gd. So we are actually getting its parents, then the RtsCamera. So this is another way you can structure your file paths. Otherwise, you would just drag and drop them inside of here, and you're going to get a direct file path reference. The issue with this type of declaring it inside a constant is that if you change the structure for some reason, you switch the player camera, this path is going to be broken if you change any type of information here. So this is the weakest form of reference you can have. So by doing a relative path, if we keep the structure, this is going to always be working. So it's something very cool. And if this doesn't work, like let's say that we don't have a folder named that, it's going to throw an error in the editor immediately because it knows that this file does not exist because it's trying to preload, and preload works on the editor itself. So it's kind of a neat trick to make sure your paths are working. So let's leave it at that, and next now I'm going to take care of grabbing the node itself. So we have the reference for the type, and now I need a reference for the object. So let's drag and drop the RtsCamera into the player code, and let's also keep Ctrl pressed so we create a new reference here. I'm not going to keep this name as it is. So the name conventions I'm using is PascalCase for the object names because it follows the engine itself. As you can see here, it has named, and I'm using SnakeCase for everything else. So now we have a type for the RtsCamera, and we have an RtsCamera object. What is the cool thing with this? If I access the RtsCamera itself and say that I want to access its property or command, so as you can see here, we have a bunch of constants, some variables. If I do this and place a dot, you're going to see that it does not bring any of those up. So if I come here and I want to reference this code here, but I don't remember, and I start typing it, so it was cam something, you're going to see that it does not show up. However, if I do something else and I omit the type for this, I don't know if this is going to actually work as I want to. As you can see here, it actually shows all the properties we have inside of that object. So the idea for you to do this is that you can pass this type here of the RtsCamera inside of functions so it can load as a type. So let's assume you have a function here that's going to expect a certain type. So a simple function, and it's going to do nothing, but we expect this RTS camera to be inside of this function. So you can say we want a camera from the type of RTS type camera. So what this is going to do is going to allow us to call the functions from this script inside of that. So whenever we say that our camera is going to do something, you're going to see that it's going to interpret this object here as a type of RTS camera. Our type of RTS camera is equal to our preloader script of the RtsCamera main. And we have access to all of these. Also included the functions we have defined here. So if I do camera and I place, you can see here we have functions for the object we have created. So this is a neat way for you to reference things inside of your objects and have the auto completion works for you. So it's something we're going to use here. So back to our task at hand, our job is to pass all of the inputs from this object to the another one. So let's go ahead and I'm going to now strip away of that. So one of the first things I'm going to do is to copy the entire feature set. So let me just copy all of our main public functions, and we're going to strip away what we don't want. And I'm going to paste it here. Now you're going to see that a bunch of errors is going to throw up because it's started to access variables and properties that do not belong on this object, but were there previously for the camera. So let's go ahead and strip away the things we don't need. And I'm going to start working on this on the camera move itself, so you can understand what exactly I'm doing here. So let's first define a new variable that is going to be called as a direction, and this is going to take care of a vector2 that is going to be used to say the direction we want to move. So for our RtsPlayer, we want to keep the inputs but not the commands for the camera. So the way that we're going to do this is by excluding all of the lines, but we are going to use only the direction. So let's go ahead and place here at the end that we want the direction of y to be equal as -1. So we are creating a direction in 2D, which is going to represent our movement for the camera for up, down, left, and right. So in 2D, -1 is actually up, so we are going to be moving the camera forwards. So let's remove this line, and I'm going to copy this one here as well for all the others, changing some things. So to move the camera backwards, we are going to assume this is 2D coordinates. So we are going to do a positive y, and let's remove all of these. If we move the camera to the left, we want to change the direction of x to -1, and if we want to move the camera to the right, we're going to change the direction to +1. And also, if we do not have a direction, so if our direction is still the same, which is equal to a vector2 0, we're going to simply return because there's no movement. So this also allows us functions to never run if we don't have any movement whatsoever. If, however, that is the case and we still have this movement, we're going to now access our camera, which we do not have a reference here, so let's add it. And this camera is expected to be of our type of RtsCamera. So we have defined a constant object that we're going to be accessing and expecting it to work, which is our RtsCamera we have developed on the previous tutorial. So we're going to be accessing that and calling the camera move function from this one. And to change that function, we're going to pass now the direction and delta. So now we have rewrote the function to only use the inputs of the player, the camera code inside of it on the camera move. So now it's expecting a direction to move. So we're going to ask for a direction, which if we remember was a vector2. It's going to pass through here. So let's copy these lines here 2 times, and we are going to remove the annotation. And I'm going to say that now the v is going to be equal to our direction in its y-axis, and here is simply going to be on its x-axis. And now all of this code now we don't need for the camera object. So now what's going to happen is that this object no longer can be called, and also we can strip away all of our function process from this camera. So the RtsCamera is not going to move by itself any longer. You're going to need the inputs of the player to move the camera. the inputs of the player are going to be placed under another object, which is going to be called the RtsPlayer. And the RtsPlayer here will be responsible only to handle the inputs and to not actually move the camera. This will be the job of the camera object. So now if we save the scene here, we're going to see that this function now works, but because we have still a bunch of things to fix, it's not going to run. So let's go ahead and continue fixing this. So our next function we're going to deal with it's going to be our camera rotation, and we're going to apply the same structure. So we're going to use a direction. If that direction is new, we're going to exit, and if not, we're going to move. You apply the camera rotate function from the camera itself. So in our case here, we are now expecting a camera type, which is going to be of type the same thing here from this one. So I'm going to actually copy these on all of our functions because we are going to rewrite them, including a camera pen. All right. So now what we're going to do is, now on the camera rotate function, change this so the direction is only left or right, so this can be a float. And now we can simply redo that as a 0. So if we press that the camera to the right is positive, so let's say that our direction now is equal to 1. And if we are rotating the camera to the other side, we're going to say that direction now is -1. And we can also remove these lines, and the code should work. Now the last thing is just to say if we have a direction, because this is a float. So if we do not have a direction, if it's still 0, it's going to return because we have no rotation. And if that's the case, if we still have a direction to rotate, then we're going to call the function itself. Now let's go back to our camera rotate function. And now let's do this code here. But this time is going to also ask for a direction, which now it's a float. And we're going to simply put this under parentheses and multiply this by our direction. So what this is going to do is going to set up the rotation based on our direction. And we're going to simply delete all of this code. So we have now cleaned both functions of the camera, of the movement and of its rotation. So now only move and rotate, but do not deal with inputs whatsoever. And we are now passing the inputs only to the player here. And as you can see, it cleaned up the camera rotate. This will be almost the same with the zoom function. So let me just copy this here. And this is going to be camera zoom. I believe I'm going to use the same name to keep this a little more simple. So the same thing, if we zoom in, our direction is going to be positive, and if we zoom out, our direction is going to be -1. So the same principle here. And if that's not the case, then we'll just skip it, so no zoom. Let's save that. Now let's go back to our camera and update the code on here as well, which is also the same thing, but is multiplied by a direction. And our direction here is a float. So there we go. And we can now delete this function. So after we finished here the camera zoom, we have cleaned it up, but this function is being called for a unhandled input, which now we want to be on the player side of things. So let's place it here. And now it's going to ask for us on other arguments. So now we're going to also pass here our camera. So it's called RtsCamera. And now it should work as expected. So we have removed the unhandled input from the camera. And now the last thing here is to comment delta because we are no longer using it. Now I believe we only have another function here to fix, which is the camera pen. So for the camera pen here on the side of the player, we do not want this one. So let me see if I have it here. So here is it. So I do not want any of this. Instead, what we're going to do is just to call the camera pen function itself back again from the camera. So by accessing our camera here, we're going to ask it to move the camera on its panning, and let's just pass here delta. And now let's pass these arguments here inside of that function. So let's go back here, and we are no longer going to have any of these. This is going to be handled by the function calls. and we're going to pass this as argument. So mouse position, which is a vector 2, is going to be needed for this function, as we are going to need the viewport size, which I also believe is a vector 2. So now the function does not expect any inputs whatsoever. We have cleaned up the code for this. Let's just fix the code here, because now it's going to ask for those input commands on these arguments. So now we're going to pass the mouse position, the viewport size, and the last one is delta. So just by doing these little bits of edits, we have stripped away all of the inputs from the camera and passed them along to our RtsPlayer node object. We have defined a type of RtsCamera which allows us to access the camera properties safely. As you can see, all of the lines here are green, which means that the editor successfully checked the code and does see that it works and works as expected. These lines here are ambiguous and we need to be run on as the project starts, and mainly because of the RtsCamera reference here. So now if we run the project, it should have the same type of feature set from the previous part. As you can see, it works. So our zoom is inverted. Let's also fix that. So here on the RtsCamera, on the player side of things, let's go ahead and invert the direction of the zoom. So zoom in is actually -1. And the zoom now works. Now the move function is not working. Let me see why that is the case. And of course, because I've excluded all the commands for the functions here, I need to call them on the player. So what you're seeing that is happening is that the zoom is the only one that works and all the other ones don't. Why that's the case? Because we have removed from the camera all the process from the camera pan, movement, rotation, and zoom. So now our player needs to do that. So I'm going to actually create a new function here and call it camera inputs. So let's do camera inputs function, which is also a void function. But inside of it, I want to now call all of the other functions we had. So this function is going to only expect a camera, which needs to be an RTS type of camera. And we also need to pass here delta to work it properly. And this function is going to call for our camera pan, our camera movement, and our camera rotates, and our camera zoom. So basically the same functionality we had previously. Now what we're going to do is pass here camera and delta, and this we're going to pass along for all of these. So now that should work, because now we have built a function to handle only the camera inputs. So now we're going to call this under the process function of our RtsPlayer, and let's just pass delta here. And now it should work properly. Only the remaining things to pass is our RtsCamera reference. So now we're going to call the camera inputs using an RtsCamera, which is the one that we loaded from our scene here, and calling all of these inputs. So now if we run the scene, we now have reformatted the whole project, and we have built now a new structure for our project here. And we also have stripped away all of the code from the camera to not have any inputs associated with it. So this type of structure here, you're going to see why in the next few parts. As we are going to add units and make them selectable, we're going to need an object to handle all the inputs. We are building towards a structure that is going to be very useful for the RTS project itself. So this is necessary work you have to put inside the project to build its structure. So now our camera code is much more clean, as you can see here, and we can actually strip away all of these comment lines. And now it does not have any inputs. So we have decided to strip away the inputs from the camera object and to only leave them on the responsibility of the RtsPlayer object. So the RtsPlayer object now it's responsible to handle all of the inputs. So this, I think it's a little bit better, and it's going to help us in our project journey. So that is all I have for now. While it's not that much, you're going to see that this type of work is necessary in building a project this big. So yeah, I'll see you on the next one, and hopefully it's going to be a new feature set addition. So I'll see you on the next video, and thank you guys for watching for now.